Well, this section, you guys, we're going to get into graphing, substitution, and elimination, those three methods for solving systems of equations. And this one, we're going to be dealing with linear equations the whole time. And let's start out with the first example. What is a solution? A solution to a system of equations. And a system of equations is just one or more equations. Okay, so you notice here we've got two equations there, right? So the question is this xy a solution is any xy value that satisfies both? So does 10,4 satisfy both of these? Well, let's just plug it in and see. I'll plug the x and the y into the first one. Is that true? Yes, it is. Plug it into the next one. See if x is 10, y is 4. See if that's true. Well, a fifth of 10 is 2. 2 plus 4 is 6. Yep, that's true as well. So is 10,4 a solution? I'd say yes, it is. 10,4 is a solution. Now there's, when you have lines, when you're working with linear equations, there's three scenarios that you'll have when you're graphing and finding the solutions by this method, by the graphing method. The first scenario is you graph the first line, you graph the second line, the solution is where they cross. So you have one solution in this case. You have one solution, and it's whatever point they cross at. Okay. A second scenario, you graph the first one, you graph the second one. Those are supposed to look parallel. They have the same slope. They're parallel. Do they cross? No. So they say no solution. Okay, that's the second scenario. The third scenario, you graph the first line. There's that line. You graph the second line, you're like, oh, it's the exact same line. So where do they cross? Everywhere. There's infinitely many solutions. All those xy points on both lines, there's infinitely many solutions. It's all xy points that they share. And there's infinitely many of them. Okay, so that's your three scenarios when you're solving these systems of linear equations. Let's go ahead and graph these. Y equals x plus 4. Remember the old y equals mx plus b. So number one, what's my y-intercept? My y-intercept is 4 here. In other words, it's the point 0,4. I'm going to put the point 0,4 on the graph. Number two, what's my slope? Well, slope is rise over run. My slope is 1, number in front of x. So I go up 1, right 1. Up 1, right 1. Up 1, right 1. Up 1, right 1, and so on. And I graph it. There's y equals x plus 4. Now let's graph y equals negative x plus 8. So my y-intercept is 8. So I have the point 0,8 right there. My slope here is negative 1, right? Number in front of x, coefficient of x. So negative 1 over 1. So down 1, right 1. Down 1, right 1, down 1, right 1 from the y-intercept, and so on. There's my y equals negative x plus 8. And then you say, well, where do they cross? Right there. Where do those two cross? Looks like that's the point 2, 6. That's our solution. 2, 6. So that's solving by graphing. Now sometimes it's not solved for y, like this next scenario. You have x minus 2y equals 10. So let's subtract x on both sides. Let's divide everything by negative 2. Divide everybody by negative 2. So we got 1/2 x minus 5. So my y-intercept is 0, negative 5. And my slope is 1/2. So up 1, right 2. So 0, negative 5. Up 1, right 2. Oops, I did that wrong. Sorry. 0, negative 5. Let me try that again. 1, 2, 3, 4, 5. Up 1, right 2. Had a wrong slope there. Up 1, right 2. There we go. Or you go down 1, left 2. Same thing. Okay, there's my x minus 2y equals 10. Now let's do the next one. X plus 2y equals negative 6. Subtract x on both sides. Divide by 2. So y-intercept of -3 right there. So y-intercept of -3, slope of down 1, right 2. Down 1, right 2. See how they cross right there, down 1, right 2, and so on. There's our x plus 2y equals -6. Again, where do they cross right there? It looks like they cross at, what is that, 2? Is that 2, -4? It's like 2, -4 right there. Where those two cross. And of course, if you plugged in 2 for x and -4 for y, it'd give you a true statement for both of those equations. It's how you could check it. Right? So, you know, when you're doing these with graphing, if you're doing them with paper pencil, ideally you got a ruler and you got some graphing paper, right, that you're graphing these with, so you can see exactly where they cross. And I mean, it's nice if they cross at integer coordinates. If they don't, you kind of have a mess on your hands, and that's where we're going to do substitution and elimination later. But let's go ahead and do this next one here. You notice this first one we have is not solved for y. So let's solve for y. Divide by -3. So the y-intercept is -5. Up 5, right 3. There's the first one. This one, the nice thing is this is already solved for. Y-intercept at -5. Oh, they hit right there. Down 2, right 1. The slope is -2. There's the green one. So where do they cross? Looks like they cross right there at 0, -5. All right, this is a good point, or a good chance right here to go ahead and pause the video and solve that thing, and we'll check it in just a second. So okay, go ahead and check your work on this. I should cross there 4-3. And let's do one more scenario with graphing here on this next one. So we got x plus 2y equals 2. I'm going to solve that for y. There's my first one, y-intercept of 1, down 1, right 2. Oops, it's terrible. There's the first one. Let's do this next one here. Subtract 2x. Divide by 4. You notice, hopefully you noticed, both of them have the same slope, right? So these things parallel. They're parallel. They're never going to cross. They're never going to cross. So you got no solution on that. All right. Well, let's get into substitution. Substitution. So if this is your first algebraic approach to solving systems of equations, and what you do is you solve for one of the variables. So you solve for a variable. I like to pick the easiest variable to solve for. So I'm not dealing with fractions, preferably. So I'm going to pick that y in the first one because it's just got a -1 in front of it instead of a number. So let's solve that. Subtract 3x both sides. So I got -y equals -3x plus 11 divided by -1. So it looks like y is 3x minus 11. So now what I do is I go into the other equation, and I got to plug that y in right there for the y. Combine like terms. Oh, I'm sorry, that 5 times negative 11, that's 55. Good grief. So add 55. So you got 13x equals 39 divided by 13, and it looks like x equals 3. So now we know that x is 3, and I can just plug it into either of the original. I'll just pick the first one. I know x is 3. Subtract 9 on both sides. Divide by negative 1. So x is 3, y is negative 2. When x is 3, y is negative 2. That's where those two lines will cross, is at 3, negative 2. All right, let's keep going. Let's do a substitution method here. And again, you could solve for anything. I'm going to take the second equation, and I'm going to solve it for x, because I notice everything's divisible by 2 on this. So if I solve that for x, so number one, solve for a variable. Again, pick either equation, solve for a variable. Solve for x. So we got 2x equals 4y minus 6. Divide everybody by 2. So x is 2y minus 3. So now I plug it into the other one. I have the other equation is 3x plus 2y equals negative 9. I'm going to plug that x in right there. So I have 3 parentheses x, and our x is 2y minus 3. 6y plus 2y is 8y. Add 9 to both sides. Well, that gives you 0. Divided by 8. 0 over 8 is 0. So we know y is 0. Now that we know y is 0, I can just plug it into either of the originals. I pick either one. I'll just pick the second one. So 2x minus 0 is negative 6. Divided by 2, negative 3. So it looks like this ends up being a negative 3 for x, a 0 for y. That's where those two lines end up crossing. Yeah, go ahead and pause it, and you can go ahead and start that next one there. 5y minus x equals negative 58, and x minus 3y equals 34. Go ahead and check your work on that. I took the second equation, solved for x, and then I substituted it into the first equation. So you should get negative 2, negative 12. Okay. Well, the elimination method, this is also referred to as the linear combination method. Sometimes you'll see textbooks call it that as well. Elimination or linear combination method. What this does is, and I think this one's nice, when, especially if you have fractions involved. What you do is you take both equations and you try and eliminate one of the variables. So like right now, if you were to add these up, 2x plus 5x, you have 7x minus 3y equals negative 41, right? Well, the problem is none of the variables eliminated. You're trying to eliminate one of them when you add them up so that you can solve for the other variable. Okay, so let me undo that. And I'm going to go ahead and I'm looking at the y. Notice on the bottom I have a negative 6y right here. So if I can get this top one to be a positive 6y, when I add them up, I'll eliminate it, right? So what do I need to multiply 3y by? 2, exactly. So let's multiply this by 2. Both sides of the equation. I got to keep the equation the same. So I multiply one side by 2 and the other side by 2. And that's what we have. The bottom one stays the same. And now notice those eliminate when I add them up. So, and then 4x plus 5x gives me 9x, and I got negative 45. So then when I divide by 9, negative 45 divided by 9, I get negative 5. So now we know. Now we know x is negative 5. And I can use either of the original equations. I'll just pick the first one. and plug it in. Add 10 to both sides. Divide by 3. So x is -5 when y is 2. Or when x is -5, y ends up being 2. That's the point of intersection of those two graphs, those two lines, -5, 2. Let's take a look at this one here, and I'm going to go ahead and let's get rid of the x on this. So my first one is 3x plus 4y is -11. My bottom is 5x plus 3y is -11. So I'm looking at my x's and I'm like, well, what's the least common multiple of 3 and 5? 15, right? So if I can get one of them to be -15, let me multiply this by -5. So that'll be -15x minus 20y equals 55. Then let me multiply this bottom one. I need that to be a positive 15. So let me multiply by positive 3. So I have 15x plus 9y is -33. And then when I add these up, notice that the x's are gone. -15x plus 15x. -20y plus 9y is -11y equals 22. Divide by -11. So it looks like y ends up being -2. And now that we know y is -2, I just got to plug it into either of the original. I'll just pick the second one this time. Add 6. Divide by 5. So it looks like -1, -2 is where these two lines cross on this one, right? All right, this next one, you guys go ahead and take a second and solve that one, and then we'll check it in just a second. All right, you guys go ahead and check your work on that. You should get 7/3, comma 1 using the elimination method. I decided to get rid of the x's, so I multiplied the lower equation by -2 is what I did on that one. Okay, this one you can use any method you want, and so why don't we go back and review substitution on this one. So I'm going to take the first one and solve for a variable. The first one is nice because if I solve for y, it's not that big a deal. I subtract 3x on both sides, divide by -1. I get 3x minus 4 on that. And now I can just plug it into the other equation, which is 6x minus 2y equals 7. Plug it in for y, right? It's going in right there. The y is 3x minus 4. Now notice 6x minus 6x, that's gone. So we end up with 8 equaling 7. Well, what's that mean? Well, 8's never equal to 7. What that means is if you graph these two equations, you get the first one looking something like this, y equals 3x minus 4. And then the other one, if you graphed it, would also be parallel to it. So they never cross. So there's no solution on this. Right, so algebraically, again, what's going to happen is you'll get something that's not true. Variables will eliminate, and you'll end up with something that's never true, right? If you get to the end and instead you get something that is true, like let's say you get 12 equaling 12, then that's the situation where it's infinitely many solutions. Right, if you get something that's always true, okay, but that's not this scenario. All right, lastly, let's do one with some nasty fractions involved here. And what I'm going to do is I'm going to use elimination because I think that's a very nice way to get rid of the fractions. So what I'm going to do first is I'm going to multiply this one by 3 so I get rid of the fractions. And I have that. And then I'm going to take my lower one, this 2x minus 5 halves. Let me get rid of its fractions by multiplying by 2 on both sides. So I have 4x minus 5 equals 34. 4x minus 5y, sorry. equals 34. And now I can use elimination to get rid of one of the variables. And I'm going to go ahead and get rid of the x's. Notice the lower one has a 4x. My higher one has a 2x. So if I just multiply this by -2, I'll have a -4x and it'll eliminate. Notice those cancel. So I have y equals -6. It looks like -40 plus 34. So now I know y is -6. And I could go back to one of those with the fractions. Or if you want, I'm just going to go back to this 2x minus 3y equals 20 because I don't have to deal with fractions. It's an equivalent equation anyways. Subtract 18 on both sides, divide by 2. So x ends up being 1. So 1 comma -6 is where these two lines cross. And thanks for watching. See you next time.